Just us. Okay, we are going to, I believe, start our next lesson. Isn't that what our module says? What's our module say? Thursday is lesson 3-1. Those quizzes that you took yesterday, I will, if not today, tomorrow, get those in the grade book so that you can see that. So today you're on page 29. Page 29 in your textbook is where we are at. Anybody have any questions that they need to ask? Have I answered everybody's emails? All that stuff? Sarai, I have your progress report. Check your test. Good. That's trash. Let me give you this. Okay. All right, so 29. What else was I going to tell y'all? I don't guess anything. Y'all, everyone's heard about the October 19th is the new date for return of our entire hybrid students. So there will no longer be A or B. It just will be students in the class or virtual. So you do have the option to go virtual if that's something that you want to do, because class sizes will be larger. But if you go virtual, then you're still going to be the ones doing everything online. Okay, so there will be no more in person. So it's totally up to you. You get to make that choice. I think that's going to happen the first week of October. You get to decide what you want to do. So that's that. Each class will be different, so there's no guarantee that you're not going to have more than 20, 30, whatever kids. It just is whoever comes. The rule is no more than 50 students or 50 people in a classroom. Well, you never have a class that's over 50 people, so you could potentially have 34. That's the maximum number of students one teacher can house. That's the rules that the state has put on it. So you could potentially have 34 people in your room. Okay. So, but everything seems to be getting better and people seem to be doing good. So that's all really positive. I personally am excited about it. I like to have my students face to face. I feel like we do better. And I can see you every day and say, I need this. You didn't give me this or whatever. So I just like that better. But what we do is really going to stay the same. I'm not going to really do things differently. It's just you'll be with me every day and not having to watch back on the videos. Okay. So any questions about that? And then Friday will stay a virtual day. So for a while at least. I bet when we come back in January, it's 5 days a week. That would be my guess. All right. Okay, so page 29. We are, thank you. Let me, perfect. Okay, page 29, we are going to use graphing, substitution, and elimination to solve linear equations. Okay, and I believe that today we're only doing graphing. I think I split this up and did several different lessons. Let me look at my module. I don't remember what I did. Notes and delta math. Okay, yeah, so it's just the graphing, I think. Maybe look at what your delta math's on so I can make sure I teach you the correct thing. I plan all my lessons on that Friday, and I can't remember. What? Yeah. Okay, it is. I wrote it on here. Just graphing. All right, so let's talk about graphing then. Okay, so it says in this situation, have you ever noticed that when an item is popular and many people want to buy it, the price goes up, but items that no one wants are marked down to a lower price? Cell phones. I mean, look at the price of a cell phone. Okay, when I got my first cell phone, we probably paid $50 for it. Now, granted, it did not do what cell phones today do, okay? But, I mean, I don't know what it costs to make an iPhone, but I guarantee you it's not $1,100 per iPhone, okay?
They paid little boys and girls in China like $2 an hour to make them.
Well, I hope that that is not true. I hope that is false news, but...
Hope and fact is not the same.
Well, I don't know. So I'm just going to pretend that you didn't say that because I would feel bad about having an iPhone if that's the case. So hoping that's not the case. But it's probably a huge markup is what I'm saying. Because why? Everyone wants one. Okay? Everybody you know has a cell phone of some type. So they get to mark those up and make us pay big bucks for it because it's a luxury. Okay? You get to have this fancy cell phone. They get to make $400, $500, $600 profit from each person. Okay, so that's why Apple has a $1 billion company. So it then says the change in an item's price and the quantity available to buy are the basis of the concept of supply and demand in economics. Demand refers to the quantity of people who are willing to buy at a particular price. Supply refers to the quantity that the manufacturer is willing to produce at a particular price. The final price that the customer sees is the result of both the supply and the demand. Suppose that during a 6-month time period, the supply and the demand for gasoline has been tracked and approximated by these functions, where Q represents millions of barrels of gasoline and P represents the price per gallon. So you've got your demand and you've got your supply. If you look at each one of those equations that represents the supply and the demand, both of them mirror Y equals mx plus b. So since they mirror Y equals mx plus b, what type of functions are we dealing with? Yeah, slope. We're dealing with linear. Okay, so we're dealing with linear equations right here that represent our supply and our demand. It says to find the best balance between market price and quantity of gasoline supplied, find a solution that a system of the two linear equations, the demand and the supply functions for gasoline, are graphed below. So what you're looking for when you're looking for the solution to a system, remember a system is when you have 2 or more, it could be 3 or 4 or whatever, equations. Doesn't have to be 2 linear, doesn't have to be 2 quadratic, it could be 1 linear, 1 quadratic, it's just could be anything, okay? But what we're looking for is we're looking for where they are going to meet. So in this case, they're saying wherever supply meets demand, that's the price we should charge, okay? So number 1, find an approximation of the coordinates of the interest. I'm sorry, I cannot read right now. Find an approximation of the coordinates of the intersection of the supply and demand functions. Explain what the point represents. So we are going to do approximation, so as close as we can. What are we counting by? 5, 6, 7, 8, 9, 10. So by ones. So where is this approximately on the x-axis? So almost 9, you could even say like 9.2, maybe 9.1, 9.3, somewhere in there if you wanted to get a little bit more specific than 9. And then what does the Y represent? Okay, and where is the price at? Right above 3. So you could say 3.2 or just 3. So, I mean, if you wanted to be super, super generic, you could just say 9.3. Showing this shows that it's a little bit more than 9, a little bit more than 3, just including that decimal right there. Okay, so what does that mean, though? What does the 9.2 represent? It says, okay, so 9.2 millions of barrels of gasoline is going to be what? Priced at $3.20. Okay, so, and I'm assuming that's per gallon. So it says that 9.2 million barrels of gasoline priced at $3.20. So basically what that's telling us is that if the company will produce 9.2 million barrels of gasoline, then companies can charge $3.20. So our demand, we are demanding 9.2 million barrels of gas. That's what we're demanding. The supply is what we're willing to pay. We're willing to pay $3.20. Okay? And that is your solution. And you can see that in this little box right here. This little box says a point or a set of points is a solution of the system of equations in two variables when the coordinates of the points make both equations true. So what we could do is we could take 9.2 and 3.2, plug it into this equation, and it should be true, should balance out. Now, we rounded, so it's probably going to be like kind of close, but let's check one of them. So if you wanted to do a check, you just plug in your X and your Y, which in this case is P and Q, and you would do the math. Okay, so I'm going to start with this, and I'm just going to plug it all into my calculator. We've got negative 0.7 times 9.2 plus 9.7. That gives me 3.26. Is that pretty close to being what we want it to be? Yeah, so that checks, okay? So when you're doing this, it should not only check in this equation, but it should also check in this equation because it is the solution to both of your equations. Now, do all lines have to cross? No. So that's what we're going to figure out on this page, is what it looks like when they don't all cross. Well, let's answer number 2 first. Number 2 says, oh, I forgot to tell y'all. Go back to this page. I need you to write your names. I haven't seen it in this class, but in my geometry classes, there is so much copying going on, and people are so lazy. Put your name in the green part. Okay, if you're writing with a pen, you're good. If you're writing with a pencil, make sure it's very clear to me, not light. Write it hard so that I know that's your name. Okay, because in my geometry classes, I'm seeing people submitting other people's pictures. Like literally they're texting it to their friend and they're not even like writing it down. They're just submitting their friend's picture. Exactly. So, and it's even so lazy that they're not changing the file name. Like it says like 45JK79 JPEG. They're submitting the exact same file. Like just dumb. Yes, and like class notes and everything.
If you're going to do it right.
Well, and that's the point. If you write your name on it, at least your friend has to write your notes. I know there's going to be cheating, but you at least have to write your own notes. You cannot submit someone else's picture. Like, that's
I can see someone being so
silly.
lazy and so complex about it that they would go and photo edit the name out rather than just write all the notes down.
You know, I've thought about that too. I have thought about that too. I'm sure that will happen as well. So again, when you're writing your name, if you're using a pencil, you need to write in the green, because when you erase the green, it discolors and messes up. So write it on the green part. If you're writing a pen, write wherever. What problems can arise when solving a system of equations by graphing? So what problems could you be dealing with when you're graphing something out? They could intersect. They could intersect at a place where there's decimals, just like what we saw. You know, we weren't able to get an exact value because it wasn't whole numbers. So that would then mean that our answer is not 100% accurate, okay? So the intersection point is not exact, then answer is not 100% accurate. Okay. Or other people have said, like, when they're graphing, what if the point of intersection is way off at, 100, 400, okay? You would not want to have to graph a graph that goes all the way to that point. So that could also be something that's a challenge. All right, so let's look at number 3. I'm going to try to get all of mine in one picture. Okay, cool. All right, so we're going to be graphing these out. You've had practice with graphing in my class already this year. When you graph, where do you put your first dot? At the y-intercept. So with this first one, where do I put my first dot? At +1. The slope is 1 in front of x. So that means I'm going to rise 1, run 1, rise 1, run 1, rise 1, run 1. It is very, very important that you use a straight edge, okay? So you need to either use your ID, your cell phone, you need to use something that's going to give you a straight edge, because we're looking for an exact point of intersection. So you don't want your graph to be off at all. So make sure you're using something as a straight edge. Then the second one, where are we putting our y-intercept at? At +4. The slope of this one is -1. So you are going down 1, right 1, down 1, right 1, down 1, right 1. You're using a straight edge. Now this kind of goes exactly with what we were just discussing. Do you know an exact solution? No, because it's kind of right in the middle of that square. So it doesn't know that, but luckily they didn't ask for that. They just want to determine how many, the number of solutions. How many solutions does this situation have?
1.
Just 1. Okay, so if they cross 1 time, you have 1 solution. You would give it to me as an XY ordered pair. Okay. Now, letter B. For the first one, where is my y-intercept? It's 5. They wrote this one backwards. Do not let that trick you. Okay. This needs to be y equals 2x plus 5. If you switch it around. So 5 is my y-intercept. What's my slope? So 2/1 means I'm going up 2, right 1. I'm on a graph, so that means I'm going to flip both the top and the bottom, because a negative divided by negative is still a positive. So I'm going down to left 1, down to left 1, and you can see your dots are still increasing because your slope is positive. Your dots are still going up 2 over 1, up 2 over 1, up 2 over 1. So you're good. There's that. For the second equation, where's your y-intercept? It's at 0. You don't have anything there. They're not going to write plus 0, okay, because that would be silly. So you put your first dot at the origin. What's your slope of this one? Up 2 over 1, up 2 over 1, up 2 over 1. What do you get? Not perpendicular, parallel lines, okay? So parallel lines, and how many solutions do they have? No solution. And why did we get parallel lines? That's right, parallel lines equals same slope. So if you have the same slope, that's how you get parallel lines. Okay? Now, if we look at C, the first equation there, where do you put your y-intercept? At positive 1. What's your slope? Up 2 over 1, up 2 over 1, up 2 over 1. Use a straight edge. Now, the second equation, is y isolated yet? No, you have got to isolate y. How do we get rid of that 2 that's right there with y? Good, they're being multiplied, so you do the opposite operation and you divide every one by 2. When you do that, 2y divided by 2 is y. 2 divided by 2 is 1. 4x divided by 2 is 2x. So it is the same equation, because if I rewrite it in slope-intercept form, I'm going to have y equals 2x plus 1, which you'll notice is the same exact equation. So if you were going to graph it, you would still have your y-intercept at 1, up 2, up 2, up 2. So you're literally getting the same equation. So how many solutions do you have if that's the case? Infinitely many. I misspelled that. Infinitely many solutions, which just means every dot that's on that line is a solution because they are the exact same. Okay, so when you're doing your delta math today, those are the 3 options that you can get for that. Okay, you can get one solution, no solutions, or infinitely many. Okay, that's how you have a solution to a system. Let's look at D. Whoops. All right, D says, graphing 2 linear equations illustrates the relationship of the lines. Classify the system in parts A through C as consistent, independent, consistent and dependent, or inconsistent. So you see that over here defined, because you're probably like, I don't know what that means. Systems with one or many solutions are consistent. So who was consistent? A, B, or C? A and C, okay, because it had many solutions. So A and C were consistent, okay. What was inconsistent? B. No solutions is B. A system with exactly one solution, who is that? A. And then a system with infinitely many is dependent. Who is that? C. So we would say that A is consistent and independent. B is only inconsistent. This is on your quiz. I do remember this is on Springboard quiz. Okay, when you take your Springboard quiz, this is on there. C is going to be consistent and dependent. That's where we're stopping. Okay, so that's the end of the lesson today. You have to submit those 2 pages of notes. That's it for submitting on Canvas. So you're going to submit your 2 pages of notes to Canvas, submit that. Then you're going to go to Delta Math, and you will have an assignment today on graphing. And that's it. Where's your book at, Evan? Okay. You got to submit those notes, so. All right, if you have any questions over the next couple of days, you know to email me, let me know. And what I've been doing is just like screenshotting your emails, because I cannot handle the red dots. Like I can't handle the red dots on my phone. So I'll open your emails and screenshot them, and then I'll go through my emails on planning period. So if you've emailed me in the last 24 hours, I probably just have your screenshot and haven't dealt with it yet, but I will. Has anybody got logged on to Delta Math yet? Can you see your new assignment? Okay, good. Daryl, have you started the Edulastic quiz yet? Come here and let me show you how to do that. I want you to do that right now. Bring your device. Do what? Has your internet's been down? Okay, well, you'll be able to do it right now. It doesn't take very long. So go to the module. Is it working? Just thinking about it. Good. You're going to algebra. Okay, so go to Wednesdays. Are you helping her, Gracie? Thank you. Go to that. Yes, Lily. I don't know. Are they?
It's normally it has to be like the exact
Cool. Answer. Yeah, it's gonna make it be the exact answer. Is it not? Continue with Google. Is it not on the number line? Has anybody else got one that's not exact? And it worked? It gave you credit for it? Okay. Well, I guess you just round. You may have to go back and click that link again now that you're signed in. But you might not. We'll see. There it is. It's 6 questions. So see if you can get it done in the next, I think you have 15 minutes left of class. Hey, does anybody have their military opt-out forms? Anybody have their forms that they don't want to be in the military? Y'all about to get some mail from the military. I have no idea. Come here. All right. So you got -8. Yep. And your slope is 5/2. Go up 1, 2, 3, 4, 5, and over 2. 1, 2. That's right. Then this one, yeah. Here, I see your mistake. -2. You did fine. You went down 1, but you only went over 1.
Oh.
So this needs to go over. I don't even know how to move it. Click on that. 2. There you go. You got it. Oh yeah, I can see y'all are working. Evan, did you get any decimals? No. Okay, see, Evan got 100. He didn't get any decimals. So I'm thinking you're probably not supposed to get decimals. So don't listen to Gracie. Okay. Oh, in the zoo. Oh,